As a board, here we go. Okay, inverse functions. So, anybody remember anything about inverse functions? It is the inverse of the function. So true. Oh, I don't know. Oh wow, you guys are, this is going to be so easy for you guys. Okay. So, I have a lot of stuff planned for today, but maybe you guys don't even need me, I don't know. Oh no, we got this. This is like a movie. No, God no. Okay, so an inverse function. Actually, this one is referred to as a relation in this one. So all you do is, it's an inverse relation reverses the pairings of a relation. Anybody want to decode that? You just switch the x and the y. Okay. So if they give us something like this, so we got 4 ordered pairs for our original function. All we have to do is switch the x and the y's, yeah? So, okay, fine, 0 and 1. So, are we done? Okay, so this is what I'm going to do. I'm going to graph these on a grid, so you should do this too. I'll give you something to do while you sit there. Okay, so we're going to graph the points and the inverse the same color. You see what I'm saying? Well, I'm going to. Okay, so I'm going to graph -4, -2. 1, 2, 3, 4. There. And then I'm going to graph -2, -4 there. That looks good. Okay, and I'm going to do 0, -3. So that's going to be down 3. And then its inverse point is at -3, 0. Okay. And then the blue one is going to be 1, 2. 1, 2. And its inverse is 2, 1. And the last one I'm going to do gray is 4, 1. And 1, 4. Okay. So if I connect the points for the first function, so I go from -4, -2, to 0, -3, to 1, 2, to 4, 1. So that's the original function, right? Okay. Its inverse is this one. An alien goat? You say so. Oh yeah, kind of. Oh, I see it. And it's like sitting Indian style. So, what is the relationship between the function and its inverse? How can we find inverses graphically? What do we do? What is happening between the function and its inverse?
He's right.
Abby, what's happening? Okay, do you guys see that it is reflected over the y equals x line? So the y equals x line cuts it right down the middle here. Okay, so if you fold, all of those points are just simply reflected. Okay, which makes sense, right? Because by definition, all you have to do is switch the x and the y, which is saying that the y is equal to x and x is equal to y and vice versa. So that makes sense why they graphically reflect over the y equals x line. I would write that down somewhere in your notes, unless you remember that forever. Inverse functions reflect over the y equals x line. Inverse functions reflect over the y equals x line. Should I write it down? I'll write it down. Okay. So, let's make it a little bit more complicated. Let's say I have this function, which is what kind of a function, by the way? Linear. 3x plus 4. So let's say I'm going to take this and I'm going to graph it. So how do I graph 3x plus 4? Oh, y-intercept is 4. Okay. Then what? So slope is 3, which is 3 over 1, so we rise 3 over on 1, but we're going to go down 3, left 1, down 3, left 1, down 3, left 1, and draw a super straight line. Ooh, that is good. So, draw the inverse. So, if I have these points, let's say we had 0, 4. And this point down here was negative 1, 1. And this one was negative 2, negative 2. Okay, what are those inverse points? 4. Oops, I wanted a different color there. 4, 0. Okay, what else? 1, negative 1. Negative 2, negative 2, right? So, can you give me the equation of that blue line? One-third x. How did you get 1/3 x? That's the slope, right? 1/3 x. What's my y-intercept? Minus. Definitely a minus, right? Because it's... yeah. Minus... minus 4? Ooh, where are you getting 4 from? I like your thought, though. Where'd you get the 4 from? Were you, like, stealing a peek at the previous equation? Is that where you got the 4 from? Just magic? Just came in your brain? Negative 2? I don't think it would be negative 2 because this is negative 2. It's got to be above that. So it's somewhere between negative 1 and negative 2. Negative 4/3? Is that just an educated guess? No. How'd you get it? What do you mean you flipped them? Flipped in the earth. You what? Fine, explain it. Go ahead.
Okay, so
Oh, okay, sorry. Fair enough. So, how do you find the inverse algebraically? Flip the x and the y, and then what? Solve for y. Okay, smarty pantses, do this one. Okay, do this one in your notes. Nope, don't graph it, just tell me what it is. What's the inverse? See if you got this. What do you do? What? 1/2 x what? Plus 1? Plus 1/2? Do you see what they're saying? Did anybody else notice the notation that I've been using? I didn't say anything. Okay. The f, yeah. Okay, so just so you know that that means the inverse of the f of x function. Okay. Can you leave it like this? Yeah. Okay, so you can leave it either way. In my opinion, I like this second one better because it's in slope-intercept form. This one looks a little scary. If I gave that to you about half the kids, some people would come up with some gnarly stuff. Yeah, people would not realize that's a linear function just because there's a big fraction. Be amazed how many people would miss that. Okay, bonus question. Ready? I'm going to call it question number 2. Okay, so I want you to find the inverse and then graph both. Find the inverse and graph both. Nikki, what are you doing on that calculator? Oh, you're just graphing it just to see what it looks like? Okay.
Yeah.
Just curious. I thought you might know some trick.
But I know there is a trick. I don't know what it is.
You're gonna make a trick. What?
You don't see the square here with your class.
Everybody done? I didn't finish yet. Okay. So, did everybody at least get my algebraic steps to where I'm going? So I added 4 divided by 3. What's my last step? Yeah. Right. So my last step is to take the square root, right? So my inverse function is the square root of x plus 4 over 3. Did anybody else get that? Okay, good. So I have not showed you how to graph the square root of anything. So how did you do this graphically? Just reflected Okay, so you just took the points and reflected it. So did you go, this point over here becomes -4 is 0, and then -1, -1, and then this one would be -1, 1. So you get this, like, sideways parabola. Okay, so I'm going to graph this in Desmos and just double check it. If that's alright with you guys? Are you ready? So 3x squared minus 4. Okay, so there's the original one. Enter. Okay, so it was the square root of x plus 4 divided by 3, right? Oh. Wait a second. What is going on here? Why is it only graphing half? I didn't do plus or minus? So I have to do a plus or minus? Oh, yeah. So how do I do that in Desmos? Oh. So do you guys see where I'm going with this? What's the problem? Why can it not just graph it as one single function? It's confused? No. Not really that there's two. You guys remember the vertical line test? How do you do the vertical line test? Anybody? You just hold your pencil vertically. Then what? Whoa. That's an X in there. That should not be there. How about that? That was way cooler. That was way more fun than that function. So remember the vertical line test? What does the vertical line test tell you? Say the last part. Then it's not a function. So is the inverse a function? No. Okay, so there's a reason why I ended with the inverse is not a function. Okay, so keep that in mind when you do your homework today in class.